Welcome to our discussion on percent problems. So, percentage problems, problems involving percents, are really quite easy to deal with if you look at the generalization basics, right? Percentage always means per 100, per always means division. So, all these little things can help you set these problems up if you're trying to translate from English into math. Some of the vocabulary, right? The base B, in these formulas will be the base or the whole, the total amount. P is the percentage and R is the rate. So when we talk about a percentage, P as being the part, it's the part over the base or the whole equals the rate over 100. So that's the general idea of a percent. But again, it's easier to just do straight translation when you're trying to do these, right? So when something is unknown, what is always X, is always equals, and of is always multiplication. So, and that holds for anything, not just percentage problems. If you're trying to solve things like this, you literally just translate it to what is 30% of 50. Solve for X. 30% of what number? Of 50 is what number, right? It doesn't matter how they write it. You're just translating, of always means multiplication, is always means equals. What you're looking for is always your variable. Percent always means divide by 100, right? So you can change 30% into 30 over 100. If you want to, if you already have worked with these, of course, you can just change that to 0.3 if you want. But that is a very simple, easy translation tool that will help you with all sorts of word problems, not just percentage ones. So let's look at a simple example. That if we're trying to solve this, right, we've got 30% times 50 equals P. We can go this way to get to P, right? But, the easiest thing is to just solve it from where it was. Just do 30 times 50, divide by 100. Bam, there's your answer, right? So oftentimes this can get overcomplicated with textbooks and examples. Just do a straight translation. And then, of course, it's always a good idea to check your answer. So, what you're looking for? Sure, you can call it P, you can call it X, right? Percent means divide by 100. Of always indicates multiplication. In the case of percentage, it indicates your base. But again, I wouldn't get involved or wouldn't get caught up in the specifics of, let's set it up specifically how percentage problems are set up. No. Let's generalize it so we can learn a technique that works for all math questions, right? All word problems. So if you're finding 8.5% of 160. Done. You don't have to worry about what's the base, what's this, blah, 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 blah. You're just running through it. How about 5 is what percent of 8? Well, again, translate. 5 is what percent of 8? Solve for X, right? Divide both sides by 8 to get rid of this. Multiply both sides by 100 to get rid of this. And there you go. 500 divided by 8, whatever that is, that's X. So I think it's much easier if you just learn basic translating than if you try and do this whole P and R and B junk that a lot of sources try and teach. Here's the third type where, B is unknown if you want to keep track of what B is. But again, it's just basically these types of questions have 3 parts. Something is a certain percent of something else, right? So there's your 3 things. Blank equals blank percent of blank. they're always going to give you two of the three. So either the first part's missing, the percentage is missing, or the end is missing. Nothing changes because it's still, this first thing is a certain percent of the last thing. And the question is, what's missing? The triangle, the circle, or the square? Well, in this case, they tell us 8.7 is 30% of what? We're missing the square. When they ask, what is 30% of 100, then we're missing this. Or 8.7 is what percent of 25, then we're missing the circle, right? We're missing that piece. So just always do this, that is your equals, of is your multiplication, and what you're missing is your variable. Set up the simple equation, do some very simple math to solve for what you're looking for, right? You're just solving for x. So, get rid of this number, or, however it's set up. I think that's going to serve you better than this whole P, B, and R stuff. Okay, let's look at another example that's got a little bit more context to it, right? It's not just a straight, simple what is blank of what. It gives you some, a big old word problem. So a moderately active adult weighing 175 pounds needs to consume 2,800 calories per day in order to maintain their weight. A nutritionist recommends that no more than 30% of those calories should come from fat. So what is the maximum number of calories per day that should come from fat, right? So we've read it all the way through. We've identified the question that we're looking for the maximum number of calories that can come from fat. And those calories are going to be 30% of the total, right? This 175 is totally irrelevant because we just want to find out 30% of 2,800 equals what we're looking for, equals our total number of fat. And that's all we got to do for this one. Here's another example. A builder told his crew that the site preparation and foundation work on a house would represent about 5% of the total building time. If it took the crew members 21 days to do this preliminary work, how long will the entire construction take? All right, so you got to make sure you understand what's going on here. The builder says it's going to take, 5% of the total building time is how long it normally takes to do just the site prep and foundation work. And then they tell you, okay, well, it took 21 days to do the prep work and foundation. So based on that, how long is it going to take to do the whole thing? So basically what they told us is that 21 days is going to be 5% of the total, i.e. 21 is 5% of the total. So now we can solve for x. Multiply both sides by 100, right? 2,100 equals 5x. Divide both sides by 5, right? And x is going to be 420 days. All right, here's our last example. They tell us that 12 milliliters of pure acetic acid are mixed with 38 milliliters of water, and we wish to calculate the percent concentration of the resulting solution, i.e., what percentage of the solution is now acetic acid. So what percent, right, of the total is acid? That's basically what they're asking for. All right, well, let's plug in what we know. Well, we don't know the percentage because that's what we're asking for, right? We're trying to find that. But we do know the total because the total is the 38 plus the 12. So what percent of, 38 plus 12, that's 50, is acid? Well, that's 12, right? So if we want to solve for x, 50 over 100, this base just becomes x over 2 equals 12, right? The 50 and the 100 will reduce. So multiply both sides by 2, and x equals 24. So 24%. Now we can check that by taking 24% of 50, right? Because that's how many total milliliters we will have. And we see that 24% of 50 is 12. And we go, yay, we got it right. Okay? So everything comes down to what is, what per percent of what, right? It's just whatever we're missing. They'll always give you two of the three pieces. All you got to do is figure out what information goes in which of the two spaces and solve for the missing third. And that's all I got for you.